All right, guys, we are ready to move on from volume. You have learned thus far how to find the volume of prisms, cylinders, cones, pyramids, and spheres. And that is really everything. Any other shape that you might want to find the volume of is probably just a combination of those. So we're going to move on from volume and start talking about surface area. Surface area is different than volume. Surface area is really just the area of the surface. Surprise, surprise. So this might become useful if you ever want to paint something. This is going to tell you how much area you need to have painted. Or if you ever want to wrap something, pretty much anytime you want to cover a three-dimensional figure, you would want to know the surface area to estimate how much material you need to buy. Okay, so what we're going to be doing today is I'm just going to do two different shapes. We are going to be finding the surface area of prisms. So this is another one of those, like if you want to do this activity at home, here are some things that you can grab real fast. So we're going to find the surface area of a prism. So any box that you have laying around is a prism. That's what I'm going to be using today. And then when we're done with that, we're going to find the surface area of a pyramid, which I actually had to make this myself, and I'm not going to tell you how long it took, but it was the highlight of my day. Okay, so pyramid, rectangular pyramid, actually. Okay, so we're going to be finding the surface area of these two things. I will go ahead and start with the prism, but first I want to kind of tell you the general rule for every surface area problem. Every surface area problem. Here's the general rule. You will always find the area of every single face and then add it all together. That's it. So you will find the area of every single face and then add it all together. Okay, so I'm going to go ahead and put that on the next screen just to emphasize it one more time before we get going on this. All right, so now that you have that in mind, something else that's going to be helpful for every surface area problem is knowing what a net is. Not like a fish net, but the net of a shape. So every three-dimensional figure has what is called a net. And you should have learned this before, but just in case you don't remember it, a net is just the flattened out version of any three-dimensional shape. So if you take a three-dimensional shape and you cut it down and flatten it out, you get the net. Pretty simple, okay? So this is the net of a rectangular pyramid. And the cool thing about knowing what the net looks like is if you can get the net, all you have to do is find measurements. All of the faces are right here. So I started cutting this out. I need to finish. So I'm going to show you what the net of a prism looks like. I'll be right back. I'm done cutting. I went ahead and cut this box into its net. And I went ahead and trimmed off any extra pieces that would overlap normally in a box. So this is truly just, one side, the bottom, the top, and then the two sides. Now here's the cool thing when it comes to finding surface area. For most figures, you are going to find that a lot of them have a twin. Okay, so I'm going to go ahead and color code for you with some crayons. What is the same as what, okay? And we're just going to scribble here. So if this is the net, I think we can all agree that the bottom is going to be the same as the top. Okay, and I hope you can see this color. If not, I can make it a little darker. Okay, so we know that the bottom is going to be the bottom of the box is going to be congruent to the top of the box. So when it comes time to take our measurements, we only really need to take one measurement. Okay, Furthermore, this side is going to be congruent to this side. So let's go ahead and grab another color, and we're going to color those sides in. That side is going to be congruent to this side. Agreed? We've got, these are the same, these are the same, and then I bet you already know these are going to be the same. I'm going to pick blue. Okay, so as you can see, we really only have 3 different sides that we need to measure, and then we're going to add them all together, okay? So I'm going to go ahead and take a picture of this, and I'm even going to go ahead and measure all of these and write the measurements down. But let's talk about a few more things before I measure, actually. So something that you might notice is that when this box is all built up, a lot of these sides touch each other. So if you look at this, you can tell that this edge, these 3 edges, let's do it this way. These 3 edges, 1, 2, actually 4 edges, 3, 4, all have to be the same. Okay, there's a lot of shortcuts going on here. You know that, let's see, ooh, I know. You know that these 2 edges have to be the same. All sorts of things. So I'm going to go ahead and make some measurements, and we're going to start calculating some area. So I will be right back. I have all of the measurements on here. As you can see, 4.5, 4.5, 4.5, 4.5, 4.5. Those are all the same. 5, 5, 5, 5, 5, 5, 5, 5. Those are all the same. And then 2.75, 2.75, 2.75, 2.75, 2.75, 2.75. Those are all the same. Okay, so we have a lot of the same things. So the next step is that we're just going to find the areas. And really all I need to do is find the area of a green, a blue, and a purple. So remember, area is base times height or length times width for a rectangle. So we're just going to be multiplying this guy times this guy, that times that, that times that. And you're going to kind of see those calculations on the next slide. And the answer, I'll go ahead and add all of them together too so that you can see it all in one step. And that's it. We have then found the surface area of this rectangular prism. So if you ever wanted to paint a box, you would know exactly how much paint to have. Okay, so that's coming to you next. So now that that's done, we're gonna go ahead and do the same exact thing, but we're gonna do it with this rectangular pyramid, all right? So once again, I would ask that you draw the net for a rectangular pyramid, which is just the base with your triangles. Now you'll notice this, everything does not have a twin. Some things have twins. So these 2 faces are gonna be exactly the same. These 2 faces are going to be exactly the same. And this guy, there's only one of them. So we're gonna go ahead and color code this so that you know what's what. And I'll go ahead and post a picture here. Okay, now we need to go ahead and make the measurements. So I'm gonna have you watch me this time so that you can kind of see what I'm doing. Remember that when we find the measurements of triangles, we actually don't need the sides, okay? Because to find the area of a triangle, you actually want the height and the base. So we're gonna go ahead and measure the height of the triangle, which is exactly 3. Okay, so I'm even gonna draw the line for the height so that we remember what this 3 went with. So this is 3 inches, which, guess what? That means this is also 3 inches. So I will show that to you, but you actually could skip this step. It's a little off. Well, give that to human error because I made this by hand. But this should also be 3 inches. Okay, similarly, the base, you need that too. The base is going to be 2 inches, which is really convenient because we also just found a side of the rectangle. Okay, so this one down here is also going to be 2 inches. So let's go ahead and take care of the other triangles. So this triangle, I already have the height line drawn from trying to make this. So the height is 2 inches. Same's gonna be true over here. The height is going to be 2 inches because they're the same. And the base is, let's see if I can get this whole thing on here. If you slide over here, the base is 5 inches. So this is 5 inches, which means this down here is also 5 inches. So we have all of the measurements we need now. Okay, so you can kind of brainstorm with me. This is going to be 1/2 of 2 times 3. So this is going to be 3 inches squared. This is also 3 inches squared. This is going to be 1/2 of 2 times 5, which is 10. 1/2 of that is 5. So this is 5 and this is 5. And then this rectangle is just 2 times 5. So this is 10. So we're going to have a 6. Do you want me to, I'm afraid, I'll write it on here. This is going to be 6 inches squared. I messed up. Sorry, that's going to be 3 inches squared. This is going to be 3 inches squared. This is going to be 5 inches squared. This is 5 inches squared. And then this is going to be 10 inches squared. So if you're with me, we could do 3 plus 3 plus 5 plus 5 plus 10, and you would get 26 inches squared for the entire. I'm going to go ahead and break that down for you and post a picture of everything together so that you can see it and screenshot it for notes. All right, so here's the last thing that I'm going to leave you with today. When you find the surface area of a pyramid, here's where a lot of people mess up, okay? We do not care. One more time, we do not care anymore what the height of the pyramid is. We don't care, not for surface area. For volume, yes. For surface area, we don't care. If you are ever given this height, it's a trick. You don't need it. Okay? Instead, if you think back, we took these heights. Okay? We got 2 and we got 3. That is not the height of the pyramid. That's actually called the slant height. So that's this height. And this slant height was different than this slant height. Okay, so be careful. Be careful that you are using the correct measurements. And I would always say, draw a net, fill in your measurements, and find the areas just like we did. All right, maybe you'll look out and you'll have a square pyramid and all of these will be the same. I don't know. If you're still watching, I'm gonna give you an extra credit opportunity.